Everyone. We are going to present the topic about risk analytics in financial services. Bank takes risks from compliance to compensation claim, so sometimes it becomes difficult to handle many risks together. There are mainly nine kinds of threats, including financial, non-financial risks associated with the financial systems. Financial risks usually are credit, market, liquidity, governance, social risks. Non-financial risks are like operational, supplier conduct, and financial crimes, and etc. All these threats affect the performance of the financial system, but credit risks are the most significant among the risks. Coming toward the problem statement, as we noted in the introduction, the risk connected with the banking system impact the financial system's performance. So in this research, we wish to look at the risk associated with clients in terms of loan delivery on time. Coming towards the project aims, the aim of the project is to visualize the futures and interpret the findings with the help of Tableau, which we are using in this project. Perform predictive modeling with the help of SAS. Recommend future works after observation of the results. Evaluation of the results using different performance merits. About the data, we have used the data sources and dataset description. Three kinds of datasets are needed to achieve the said aim: application data and previous application column descriptions, which we have defined in this slide. Coming towards the graph, as you can see, it is the interpretation using Tableau. Here you can see the interpretation from the plot tells the female customers are usually more than the male customers. As you can see the graph, in the graph you can see gender biased loan defaulters. Here the female percentage is bigger than what we see with the male percentage. The female percentage is highlighted in the blue color and the male percentage is highlighted in the orange color. Coming towards the next slide, you can see this slide. It is the loan defaulters based on the own cars. The interpretation uh, from the plot above tells that the owning car has nothing to convey, then there are less customers who defaulted loans and own car. The customer who own cars also paid the loan more than the defaulters, as you can see in the light green color, and another one is the red color. Thank you.
Hello, Professor. My name is C.H. Saithaja Reddy Chimala. I am going to continue our presentation. Income type interpretation of the plot tells that income type has nothing to do with the default loans. Most of the customers are working and paid loans. As per the ratio of the customers in the data, it seems loan defaulters are more in the states around class. Let us see the income based on business and family status. From the interpretation plot, business persons earns more than any others. The least average income earned by the employed persons. Let us see the income based on education. From the interpretation plot, that the who are having an academic degree have higher average income. Let us see the income based on occupation. From the interpretation plot tells that income based on occupation, where managers have high average and cleaning staff have low average income. In this loan defaulters on days of employment. In this interpretation plot tells that loan defaulters on day of employment were employed is directly proportional to the loan defaults as people. With the help of Tableau, we just visualize some of the important features responsible for defaulters, male and female default loans, how people having cost different default loan, how people wearing the different income type tends to default loans. These are the some of the features visualized. After that, we have done SAS overview, where we have classified loan defaulters with the help of decision tree, gradient boosting, DM neural, and autoneural. DM neural and autoneural are basically neural network techniques, and we have used that for improving the accuracy as data in our case is highly imbalanced. From the decision tree, we can see the samples belonging to the default customers are very less compared to the normal customers. So here we can see the data is extremely imbalanced. So which is why we have used neural networks to overcome the imbalance. We can see the decision tree gives time high MIS classification in loan defaulters, and the model is not suitable to handle imbalanced data.
In this table, you can see that model is trained on 7,739 samples and tested on 863 samples, and the misclassification rate in training data is 0.058 and the misclassification rate in test data is 0.066. When coming to gradient boosting results, here in the gradient boosting classification, the misclassification in lone defaulter samples are higher and almost all the samples are misclassified by the algorithm. However, the normal customers are correctly classified by the gradient boosting model. From the above table, you can see that the goodness of fit statistic, the misclassification rate is observed. In the training data, the misclassification rate is 0.0596 and the misclassification rate in test data is 0.0637. When coming to DM neural results, in this network, highly misclassified the lone defaulter samples in training data and gave the 100% accuracy in classifying the normal customers of the training data. From the above table, you can see that from the goodness of fit statistics, the misclassification rate is determined and the misclassification rate in training data is 0.0608 and the misclassification rate in test data is 0.0625. When coming to auto neural results, in this model, it gave the best and the lowest misclassification in trained data for both the classes. Despite low samples of lone defaulters, the model predict with 100% accuracy. From the goodness of fit statistics, the misclassification rate is defined, and from the above table, you can say that the misclassification rate in training data is 0 and the misclassification rate in test data is 0.127.
Coming to model evaluation criteria and the final model, the ROC curve is used to compare and evaluate all the models. A ROC curve is a graph showing the performance of classification model at all classification thresholds. From the graph above, we see that the sensitivity of gradient boosting is higher than the other algorithms. On the other hand, the lower sensitivity is observed in DM neural model. Coming to misclassification rate, it is a metric that tells us the percentage of observations that were incorrectly predicted by some classification models. The value of misclassification rate can be ranged from 0 to 1. 0 represents 0 incorrect predictions, 1 represents completely incorrect predictions. The misclassification rate is used as evaluation for all the models, and from the above graph, the autoneural model gave the least misclassification rate than the other algorithms. From the graph above, the final model is the autoneural model and the evaluation criteria are the misclassification rate in trained data. Because the DM neural gave the highest misclassification rate in the data, whereas the autoneural model gave the lowest misclassification rate in trained data, which is 0, which represents a model that had 0 incorrect predictions. Coming to interpretations of findings from the graph with the help of state export function in SAS, the most important features are organization type, occupation type, contract type, etc., which are highly important in predicting loan defaulters. For predicting loan defaulters, autoneural model is the best model as it gives highest accuracy and gave no error in such imbalanced classes. Coming to recommendations, the information must be completely balanced. To achieve that, the data update is necessary. The performance or risk prediction model will grow due to highly correlated characteristics. The performance may be enhanced by the model tuning using the best settings. The model should be created in Python or any other programming language. Coming to summary and lesson learned, we gain knowledge how to use Tableau for risk analytics visualization and also SAS machine learning implementation and Python data pre-processing. The original data had several odd observations that were eliminated and pre-processing techniques in Python were used to fill the missing values. We were able to clean the samples and eliminate all unnecessary columns. We know now how to prepare the data. Additionally, we learned how to use SAS to create the models and why autoneural model is the best one for identifying loan defaulters. Coming to future work, data has to be cleaned up and additional customers' data from other locations need to be uploaded. Additionally, data should be cleaned up while it is being collected so that additional time won't be needed for cleaning when adding new data. To choose the relevant characteristics that will provide high forecast for loan defaulters, the feature name should be cleaned up and the feature reduction techniques can be applied.